activity that takes place in the hurricanes will drop what are called drop zones, little weather monitoring instruments, and they fall down through the hurricane and they monitor that. While we fly over the top, NOAA or the Air Force or Navy will fly aircraft through the hurricane. So we get different amounts of data, and then that is given over to that is given over to meteorologists, and they will crunch on that data, and after a while they'll kick out papers, improve their models, so we get better weather forecasting and that type of thing. But we do all kinds of things like that. So I'm going to turn this over to Tom Miller. He's a pilot of these aircraft, and he will explain a little more in that aspect of what the characteristics are of the aircraft and that type of thing.
Okay. Yeah, so I hope you guys remember from yesterday. I remember
you were wearing your pilot suit.
We kind of went through some of this stuff yesterday
at our Google Glass.
Social event we had. So these are the airplanes that I was talking about, the Global Hawk, and the two airplanes you're looking at here are actually some of the prototypes. That aircraft there was the first one to fly back in 1998, back in February of 98, Air Vehicle 1. So that's kind of a one-of-a-kind, was built by Orion Corporation, and then there was a competition between Orion and Northrop to build this high-altitude, long-endurance, unmanned aerial vehicle, and Orion won the competition. So Northrop's answer to that was they went and bought Orion. So now Northrop builds all of these, and this aircraft here, it was Air Vehicle 6. It was the sixth one off the line, and it was the last of the demonstrators. Then we moved into the production aircraft, which you see right over there, a Block 10 production aircraft. So those were the workhorses that the Air Force and the Navy used for many, many years. Now they've transitioned to a new model, which is actually bigger. It's got a larger wingspan, about 132 feet. The aircraft is a little bit taller, carries more payload, 3,000 pounds versus the 2,000 pounds that the smaller aircraft carries. So big improvements on that. And now the latest version is called the Triton, which the Navy is using for maritime patrol uses. And that's got a beefed up wing and all kinds of other improvements that they made to the aircraft for the Navy mission. So I don't know how much you know about the aircraft, but it was designed to be a fully autonomous air vehicle. And we can literally plug a mission plan in. It takes a few weeks to generate a mission plan for one of these. We put a mission plan into the aircraft, and that mission plan includes everything. It has a taxi pad for the airplane. The airplane will taxi out. It will stop at the last taxi waypoint. It hikes up the nose, and then it waits for the pilot to send the takeoff command. Send the takeoff command. It will go and fly its whole mission, take all of its pictures, come back and land all on its own without any pilot intervention. And that's really great unless you have weather, unless you have other aircraft, or unless you have something go wrong. So that's really what the pilots are there for, is to monitor the aircraft when it's on this autonomous mission plan. And then, like we do with the airborne science mission, we don't run it on this pre-planned mission because we chase weather, and weather has a tendency to move on you. So we actually just put it into what we call the override mode and fly it around wherever we need to the storm. But the unique thing about the airplane is that also in this mission plan, it also has contingency logic. So at every waypoint, we tell the airplane, if you lose the command and control link, go do this. If you lose some critical redundant component like a hydraulic pump or flight control actuators, do this. Come home via this route. If you lose the engine, do this, which since we fly over water most of the time, a loss of the only engine is a ditch. But we haven't lost one yet. And we haven't left one up there yet so far either. So it all works pretty well. So Mark talked a little bit about the mission. I told you guys a little about the hurricane mission yesterday. This new one that we're getting set up for is again to discover or to research cold air masses out in the Pacific this time. The airplane itself is pretty basic. It's a real study in off-the-shelf parts. We've got the engine out of a Cessna Citation, the landing gear off of an F5. So just that's about it. Does anybody have any questions?
So it's like a Heinz 57.
Sort of like a Heinz
Mix up
57, you
everything.
think of it that way, yeah. And it is literally, a lot of it is commercial off-the-shelf parts.
So it'd be the UAV pilot with an automatic flight plan. Just kick back at the desk.
Yeah, we play a lot of solitaire. Now, actually, there's times when it gets really, really busy, especially when we're chasing a storm, because as I said, every time we do something different, we got to go back to whoever is our controlling agency, air traffic control, and refile a flight plan. So it's constant, you know. And for an airplane that flies 24 hours, flight plan has a lot of waypoints in it. So it's, you know, it's not the stick and rudder flying. We fly it with a mouse and keyboard, but we're required to maintain currency and man the aircraft also, so that we stay smart on airspace and procedures.
So where's your flight?
It's upstairs, and actually we're going to walk up there in just a couple of minutes and take a look. The guys are up there running a sim right now. But, does anybody have any questions while we're here standing at the airplane?
Over here.
Yes, sir.
You said it's autonomous and then you can go into an override mode. If you've got it out on a big, long, 24-hour flight plan, you have to go into override mode to go look at something else.
Yeah.
Then release it back and it will find its way back on the path.
Yeah, we direct it back, and what we do is we leave it tied to one of these waypoints in the mission plan, and again, that's where all the logic is for the mission plan. So, for example, you know, if I tell the airplane, okay, if you lose the engine here, go land at this place, and then I put it into override, and then if I'm not paying attention and I'm stooging around out here, I'm suddenly 1,000 miles away from that waypoint. Well, it's not going to make it there, you know. So we constantly have to juggle that around too. And again, if the airplane, even if we lose all of the command and control links, it'll come back home and land. All by
Wow.
itself, or land wherever we told it to go land in the mission plan.
That's pretty cool.
What is something that one of these planes has done that has helped us, just the regular Joes of the world that you can think of, that like it's flown into hurricanes? So what did we learn from that? Or something that we can tell people?
Well, like I told you yesterday, the drop zones that we were throwing out of this airplane in this last campaign was actually feeding data right back into the weather models and improving that model by very little bits. But that's going to determine what the scientists are trying to learn is what makes a weather system. We get these tropical depressions, or we get what they call pouches, which is this layer of air that comes off of the Saharan desert and it's carrying dust and it's carrying a bunch of other junk with it. And then it hits a spot over the ocean, and whatever combination of temperature, humidity turns it into a tropical depression. That's where we want to study that and say, okay, what's going to make this turn into a storm? Or what's going to make it peter out and turn into nothing? When the scientists can understand that, then they're going to have the ability to predict that and predict it much earlier and evacuate coastal areas or batten down the hatches out there. So, you know, the improvements that we've made in weather prediction over the years, I think has saved a lot of lives and saved a lot of property. The idea is to,
Was the
is
plan
to
to
improve
do into tornadoes as well?
we don't fly this one over tornadoes specifically, but a lot of the data that they're learning could apply to tornadoes. I'm not a weather guy, so I'm not exactly
It'd
sure.
be hard to catch a tornado.
Well,
Kinda
I mean,
bring it
but-
down sporadically. It's not like a hurricane where you see it building.
No, but if you understand the conditions that lead to a tornado forming, that gives you the ability to predict it, or to at least predict the threat of it.
And they tend to run at
Just
the
some
same
quick
direction.
data on the aircraft. Wings are 100. The wingspan 116 feet. The aircraft sits up about 40. It was 44 feet long. Sits up about 15 feet
And
high.
I heard you say
So
you're
that's-
going to lengthen the wingspan?
They've already done that.
On
Oh, it's already
not
done.
on these.
Not on these.
The ones the
No,
Air
that's-
Force are flying, it's
How are you going to
100
fit them in this hangar if you?
We won't.
Seriously.
Yeah, we'll have to work that.
Yeah.
Probably not as many aircraft. Okay,